We now talk about inductance. So say there are two coils which are right next to each other, and the flux change in one coil can produce current in the other coil. So since you're changing flux in one of the coils, the other coil will also experience this change in flux because they're close to each other, and because of Lenz's law, the current will be produced. So when the flux to the coil changes, so each turn of the coil contributes to induced EMF or current in the other coil. So the flux changes, it changes turn by turn, turn by turn, turn by turn, and that induces current or EMF in the other coil. Now say if there are n turns, we will get n times the flux is directly proportional to the induced current. So this is the current which is induced. So this is the induced current. And the proportionality constant we denote by L. So you have N phi is equal to Li, or this proportionality constant is nothing but N times phi over I. So this proportionality constant L is called inductance. So the units of measurement of inductance is Henry, and the dimensions are M, L2, T raised to the power minus 2 and amps to the power of minus 2. Now we talk about mutual inductance. So say there are two coils as shown in the figure. The coil 1 has turns N1 and the coil 2 has turns N2. Suppose current I1 is passing through coil 1. So the current I1 is passing through coil 1. So this current will pass when you put the switch on the on position. So notice that the current has to change. So the current will change only when you immediately put the current on. If I put the current on right now, that is make the switch on, then the current will start flowing. But the current will take some time to reach steady state. So when the current is increasing, there is a flux. So there is a flux which is passing through, which is being produced here. So this flux is so let us write this flux like this. So this is how the flux is coming in through the coil and going out. So this flux also passes through coil 2. So this flux we will call as phi 1, 2. So it is produced by 1 and it acts on coil 2. So the mutual inductance of coil 2 with respect to coil 1. So this is coil 2 with respect to coil 1. This is given as M12 is equal to N2 times phi 12 divided by I1. So this is just a copying this formula down. We have just copied this formula down here, replacing L with the M12. So electromagnetic force induced in coil 2 by coil 1 by a time varying current. Notice that the current should be time varying. So the current will be time varying in this battery operated system only when you throw the switch on or when you throw the switch off. So in between, when the current is steady, then there will be no EMF produced. So we will see this in a minute. So the EMF produced in coil 2, so the EMF will be produced in coil 2. This E2 is given as minus N2 times d phi by dt. So this is the formula, standard formula. So this flux, from here you can see the flux is phi 12 is M12 times I1 over N2. So you plug this in the equation right here. This is a proportionality constant, it comes out, N2 cancels with N2 and you get minus M12 times di by dt. So you have di1, the current representing here. So if the current is flowing at a steady rate, that means the current is flowing at a constant rate, then this becomes 0 because the current is not changing with respect to time. And in that case, EMF would be 0. So the current is not in a steady state when you just switch off or when you just switch on. So you can repeat the same procedure and replace coil 1 with coil 2, having current I2. So you can have the same procedure. Instead of I1, you can have I2 flowing in the wire 2, and you can talk about the EMF produced in wire 1. So generally this M12 and M21 are the same because the material is the same. These are ideal solenoids or ideal coils, you can say. So we can generally write as E1 as minus M di2 by dt and E2 as minus M di1 by dt.